Okay, today I'm going to talk about web application security, risk involved in web application security, and how we can improve the security in web applications. Uh, Something about me. I'm a senior security engineer at T-Mobile Washington. Prior to that, I worked in DC government and Bank of America. I have expertise in web application security testing, architecture risk analysis, vendor assessment, and security training solutions. Like I said, my agenda for today is to talk about how software and software complexity is increasing and how security needs to catch up, risk and breaches, and how we need to improve, and application security risk. The solution which I'm proposing is which we all are doing, but we are still missing a lot of things. How to do it right? We're going to talking about moving left in the SDLC, and then we'll be going through all the phases of SDLC. And then after that, if you have any questions, we can obviously talk about those. There was a time when large software application used to take long time to complete, which is not the case today. Agile teams can deliver application software in weeks and days now. Speed of software development has increased, and so are the software security risks. Development team is focused on speed and pushing applications into production, which sometimes causing like hundreds of commits every day. Organizations are taking advantages of cloud platforms, on-demand services, and continuous delivery pipeline. All of these are basically increasing delivery cycle time. But the main question is, where is security in all of these? What does security look like in the world of continuous change? And how can security team can possibly keep up with all these changes? We do have some gating control in place. We have security testing, we have DAST, which is my bread and butter. We have penetration testing, but are these all sufficient? Let's talk about some stats. Verizon recently published its 2020 Data Breach Investigation Report, DBIR report, which analyzed 32,000 security incidents in 16 different industries and 4 different world regions. Majority of these breaches, 86% of them are financially motivated. More 70% are caused by outsiders. And most important, the worth noting fact is that applications were part of more than 43% of breaches, more than the double the amount from last year. DBIR found that the cause of the increase in web application breaches was a result of more people moving their workflows to the cloud. There was another report which was stated in State of Software Security, which found out that retail industry, 40% of applications are only scanned once a year. Can you imagine that? Only once a year. By increasing the number of scans, the retail industry could find and remediate more flaws and address security issues. The higher the percentage of breaches where web applications were the primary attack vector, this shows us the improvement required in application security. This is how the criticality is there in web application security. Now I'm going to talk about application security risk. In the light of current pandemic, with more and more businesses undergoing digital transformation, number of web application breaches will definitely likely to increase. No doubt in that. Application security is becoming an important priority for all organizations. Whether you are a multinational company like Netflix or Twitter, if your business is online, web application is important. Even if you're a small mom and pop store, if you're going online, this is important for you. It's your customer data. It's your brand value which is at stake. So developments in web applications and services have improved the way that company used to do business like 10 years ago or 20 years ago. They have also increased the risk of malicious attack as well. Simply put, the current weak link in most organizations is the application security, which is a main important discussion we are going to have right now. Let's think, does everybody in the organization know that how many APIs you are using? Do you even know what data is being shared in those APIs and how it's being shared, how your customers, your partners or vendors are using those APIs? Many organizations are not even keeping their API inventory up to date. And if you're not aware of your APIs, how will you protect, secure, and monitor it? You need to enter all your APIs in API registry, whether it's new API, old API. Ask your application security team to find those APIs and assess them as well. Over here, I'm talking about application security risk. It's important for everyone to know about some common application security issues, such as broken authentication, XSS, sensitive information disclosure, injection, session management. I know a lot of us are familiar with all of these, so I'm not going into detail on all of these issues. But yes, I'm going to highlight OWASP top 10 here, which is a top 10 vulnerability, and it's an industry standard. We have to cover those. So, what is moving left in SDLC? Let's talk about what's happening in the organizations. Organizations are trying to secure their application. They're following industry standard, best practices to invest in penetration testing with application firewall. But despite these efforts, many AppSec initiatives fall short, and they fail to adequately secure business critical functions. So what to do? The best solution is to use a secure software development lifecycle, secure SDLC, and start security discussion right from the design phase. So whether you are developing application in-house, outsourced development, or purchasing application from outside vendor, you must be able to ensure that secure development practices are being followed. Interestingly, there are many studies that shows it's faster, easier, and cheaper to find and fix secure software issues early in the development cycle when coders are actually writing their code rather than waiting in the testing or the QA phase and in the production. Hopefully, we are not doing that in production, but yes, it's important to assess your application in the early stages of the SDLC cycle. Security should be baked into the process from the start. So we need to move left. Moving left eliminates unnecessarily workload. Instead of fixing the issue identified in penetration testing, which happens after your code is already in production, development team should work instead in the earlier cycle to find security vulnerability. Security team should be involved from the start of the SDLC cycle. Here I'm talking, if you can see on the slide, here are the different phases of SDLC cycle. Each step in the SDLC requires its own security enforcement and tooling. From design to the test to the deployment, each phase is extremely important, and we have to make sure we are following security in each and every phase. I'm going to walk you through each and every phase, and we will talk about how application team and security engineers have to work together to achieve the common goal of defense in depth and secure your application and customer sensitive data. Security requirements should cover security policies, mechanism to enforce those security policies, authentication, authorization. So you don't have to wait. You need to involve your security engineer right from the design phase, right from the beginning. Let's talk about the design phase first. It is critical to involve security team to review the design document, perform threat modeling, write down all the security requirements that needs to be considered. It is extremely critical when application requirements are defined, the corresponding security requirements should also be defined. Yes, that's where we are lacking. Security requirements should cover security policies, CIA, mechanism to enforce those policies. So you don't have to wait. It means you should involve a security engineer when you're creating a design document. And I'm repeating here because it's really, really important. Security engineer will review your design document, work with the application team to improve the security posture of the entire application. So let's talk about what a security engineer gonna do. So there are common questions a security engineer is going to ask about the development team, about the application. So on this, let's go to the next slide first. On this slide, you can see a list of few questions which you need to think about. And most importantly, security engineer will ask you these questions while doing a design review of your application. So the first question is there a data flow architecture diagram of an application? And you'll be like, it seems so simple, right? But it's not. That's where we are missing. I hate to say, not all applications have a data flow diagram. And I'm not talking about legacy applications. It's extremely important to have a data flow architecture diagram. You need to understand all the entry points of your application. You need to know all the components involved and assess them individually. Next is, you need to know what is the data classification. Is it restricted? Is it confidential? Is it PCI? So if it's going to be restricted, if it's involving SSN, yeah. If you have date of birth, if you have billing information, it's all restricted. If there is a payment history, your credit rating, then it's PCI information. If you are dealing with the EIN number, your ITN number, then it's your confidential information. Depending upon the type of the data you are dealing with, you need to have controls in place. And the main reason why we are discussing this, because you need to set appropriate controls based on the classification of your data. You will be surprised to know how many developers keep the confidential information in the plain text. So imagine if you're a hacker and you found unencrypted credit card information. Yes, it's unencrypted. It will make hacker's job super easy. He doesn't need to do anything. Think about it. Think about it when that credit card information is stolen. It's attacked, it's in an attacker's hand. So what about customer trust and business? It's impacted big time. So what we need to do? So if it's confidential data, you should encrypt it. And not only that, you need to make sure you are using latest algorithm, because obsolete algorithms are not going to help you. Obsolete algorithms have their own security flaws which make them insecure and vulnerable. So you have to make use of latest algorithm. So next we talk about if there are any APIs involved, how those APIs are exposed. So if your application has APIs, so let's say yes, you have those APIs. So the question comes is it intended for internal use, external use, or who's going to access those APIs? Who's the end user? So if it's intended for internal use, it should not be exposed to public. In my experience, I have seen many internal APIs which were exposed to public. Yes, it sounds crazy, right? Some of those API had restricted information. And as it has a restricted information, it was a high critical security issue. Sorry about that. High critical security issue to expose those internal APIs. Any hacker could have easily exploit those APIs over the internet. And since it has a restricted information, is the biggest impact on the business and the brand value, of course. I have seen many application owners who don't know, they're unaware of the security. What they are doing is they are exposing this API so that their third-party vendor can access it, because that's the reason they think about it. But in that case, what you can do, if you have a similar scenario, you should set some restrictions based on IP address. Only those provision IP addresses can access those APIs, nobody else. If your API is intended for external use, for public use, make sure it's behind your web application firewall. It should also be registered in your API inventory record. Now, let's talk about vendors. Are vendors or third party involved within the application? Did those vendors have a security evaluation? Interesting questions, right? This is a blind spot in many organizations. not just the new vendors you are dealing with. If there is an old vendor you are working from last 5 or let's say 10 years, you have to make sure there's a security engineer assigned to perform vendor assessment on that. If there is an old contract that doesn't have a security requirement, then you have to make sure your supplier management team can renew contract only when there is a security requirement in place. That's where your security engineer will help you. Just like your internal application, vendor have to go through the regular testing, design reviews, penetration testing, because it's your customer data at the end. And you are the company, as a company, you have to review that this vendor is doing what they are supposed to do. Now let's talk about, is there a regular patch management, code scan, internal, external testing being done? So you have to ask the application owner, when was the last time the application was assessed? Is it a part of the patch management? If it's not, it's a red flag. Same goes to the regular white box testing and annual penetration testing. There's a general recommendation industry-wide that you should always do patch management once a month. Now we are actually going more frequent. That's actually the bare minimum once a month. White box, vulnerability management quarterly, and annual penetration testing. Similarly, there are many other things I can talk about. There are big lists we can see right now. I can go long in each and every list. There are many other questions which are very important, and you have to ask your application owner, like infrastructure, your network security, your authentication method. It's a big list. I'm not going through all of the lists because of the time constraint, but yes, that's really important to think in mind. Okay, so let's move to the next build phase. This is a time when developers start writing their code. There are many plugins which can be used to find security flaws right away. It's essential to assess security code regularly, and the best way is to integrate code scanning with CI/CD pipeline, which means every time you commit a code, a new scan will be done and new issues will be identified. Code scanning is really, really important. Many high critical issues, such as hard-coded password, can be identified in the code scanning, right in the build phase. Fixing such issues a lot quicker in the build phase without causing any delay in the release cycle. Fixing issues identified in the source code is really, really important because it's a low-hanging fruit. You really don't want to miss it because it has a really high potential risk impact. Industry-wide, number of code scan issues are generally higher when you compare it with your web application, your penetration testing. But it is critical to address those findings and verify if it's fixed or not. And most importantly, we have to make a plan to fix any open issues. You have to track those issues, have SLAs. Someone should be accountable for those potential risks. Otherwise, it will never get fixed. Another critical thing in this phase is to give security awareness training to the dev team. Educate them. Educate them about the security best practices. It's your job at the end. You're a security engineer. Many a time, dev teams are not aware of key risk factor. They don't know what's the risk involved with the data security, privacy. Some employees are misinformed, confused, ignorant. Yeah. Many don't understand that cybersecurity is their personal responsibility. And even there are few, they don't even know about sensitive data privacy best practices, which is really important. Security is everybody's responsibility. Even a small mistake can have bigger consequences. So that's why security awareness training will help everyone in the organization to be on the same page. And eventually, this will reduce risk, incidents, and help the entire workplace. Now I'm going to the next phase, which is our test and release phase. So it's really important to perform testing in the non-production environment before going into the development phase. Here we want to test our web application, should be, yes, that's really important, which should be a mirror image of your production environment. In this phase, we will test web applications, APIs, before they actually goes into the production. In this phase, we're going to test about many scenarios like session management, cross-site scripting. However, in the last phase, where we perform the source code testing, which is independent of this testing, here we're talking about web application and API. The last time that we talk about the hard-coded password, let's say, those are different than the issues identified in this phase, because here we are dealing with the real-time application. And the last one, we were dealing with the scanning the static code. But it's really important to test both, and both are really individually important. And we're not supposed to miss any of those. Last is our deployment phase. In this phase, your code is already in production. You have already done all the checklist. So what's next? Very important. Security is still important. Security does not stop because you have reached deployment and implementation. Because even after deployment and implementation, security practices need to be followed. We need to be continuously test our application for any new vulnerabilities. There are tons of zero-day vulnerabilities. So we need to make sure that we are continuously testing those. It's a good practice to perform a regular penetration test on the production environment. So now, what's next? We talked about all the phases. Implementing security SDLC helps you follow security best practices, integrating security activities and checkup across development phase. This will help you increase the security posture of your organization. But you have to create a security culture. You have to work with the development team, not against them. It's a collaborative effort. You have to make it fun. You have to make it education for them. So there are various ways to make it fun. You can have team competitions. You can have hackathon. There are fun ways to involve everyone in your journey of securing web application, because it's your own organization and it's your own customer data. And the last thing that I'm going to talk about, measure the practices. Have a dashboard. Track your high-risk application. Number of open security issues. How much time people are spending in fixing those open issues. Are they actually getting fixed, or they are open from a long time? Because if they are open from a long time, then you have to escalate it. You have to make somebody accountable. So have a dashboard and make sure it's being regularly updated. And list all the top 10 security issues in your organization. And last, measure, plan, and keep improving with moving left in the SDLC. That's all I have for today. Now it's Q&A. I will be in the booth for Q&A section, and you can also tweet me. My Twitter handle is 21 Kaur Jaswinder. I'll be there if you want to answer, and if you have any questions, I'll be happy to assist you. Thank you so much for having me.